Hi, this is Shakil Ahmed. In this tutorial, we will discuss about the repeated Measures ANOVA, where we have repeated groups. Basically, we have observations on the same individuals for three different time points or more than three different time points. So this is just an extension of a paired sample t-test where we have two groups before and after certain interventions. But uh, when we want to compare for more than three occasions, we have samples for more than 3 points, then we need to perform a repeated Measures ANOVA. So in repeated Measures ANOVA, we need to find two sources of variations, one by three groups and one by the individuals. So I have just describe the data for three groups. That is group 1, group 2, group 3, each having uh, 10 individuals, basically the same 10 individuals. We have total 10 individuals, but we have 30 observations. Each individual was measured three times. So these are the means for the three occasions, and these are the standard deviations. And basically here the assumption is that the differences should follow a normal distribution. We don't need uh, the normality of the groups within group data. So we need to find the between group variation and subject between subject variation, and then uh, between within variation, that is called error sum of square. So first of all, we find the variation between groups that we have already found. First of all, we need to find the grand mean. What is the grand mean? You can just find the sums, although you can just find the sum of the mean of these three means. As we have equal number of observations, we don't need to find the weighted mean. We just can find the mean. That the mean is 144.03. This is grand mean. So we will find the total sum of square just like we did in previous example. So it starts from this observation minus grand mean. And to fix the grand mean, you can just put a dollar sign and square it. This is the sum of square, and we can just drag it, although you can just give the identity so that it will be easy for you to drag. Otherwise, you can, sorry. So you're not making some patterns, so we need to just write the things 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And you can just drag it for 10 observations, and then drag for three groups, and you can find the total sum of square deviation from total mean or grand mean. So this is the grand total sum of square. You can just copy it and paste it here. Now we are interested in finding the between sum of square and subject sum of square. So you need to find the subject wise mean for each subject, the mean of the data sets. So we should write it as average and then just drag it and just copy it. These are the means, and you can just find the deviation from mean. This minus grand mean. Where is the grand mean? The grand mean is here. And then square it. And sum it. We don't need to make a weighted sum as the all the size of the all the three groups are same. We can just multiply it by 3. So this is the between subject sum of square. You can just copy it and you can find between group sum of square this minus this and then square, and you can just drag it and then you can sum, but you can need to multiply it by 10 as each group has 10 observations. So this is between group variation. So you just copy it and then within sum of square, that is total sum of square minus sum of square minus the sum of square. And the degree of freedom is k minus 1, that is 2. And between subject, how many subjects we have? 10 subjects, so it should be 9. And it is, we have 30 observations, 30 minus 1, 29, and 29 minus 11. It should be 19. So the mean square error is just this divided by 2, and this divide by 9, and this divide by 19. So we can find the F statistics for between groups, divide by this, and the F statistic for this, you can just check. So the between group F statistic is 533, which is so high. So we can easily conclude that there is no significant difference. The three groups are significantly different. The three means are significantly different, or the mean diastolic blood pressure is different on three different time points. And you can find the p-value using F distribution with this value and degree of freedom 1, that is 2, and degree of freedom 2, that is 19. And the cumulative is 2. And it should be 1 minus this, as it will provide the area below the critical value. So we need area above the critical value. So this is the p-value that is very significant, 0.000. So we easily conclude that there is no, the three treatment means are significantly different from each other, and you can again perform a post hoc test whether the different pairs of which pairs are different and which pairs are same. Thank you.